Hello, we are Group 14 of the Spring 2019 semester with Iowa State University's IMSE department. We're working with a steel manufacturing company that specializes in processing scrap metal into steel products using an electric arc furnace. The temperature of the steel needs to be taken before it begins the next step in the process. Currently, 2 operators are required to use a thermocouple sensor to take the temperature. The probe uses a sleeve that must be replaced each time, and if the temperature is not correct, the furnace needs to be reheated, causing a time delay and safety hazard.
This project was a continuation of work done by 2 prior groups. Based off their findings, our objectives for the semester were to determine an optimal cladding method for properly protect the fiber and to create a protective jacket that will prevent the cladded fiber from cracking. To complete this, we performed 5 phases of experiments throughout the semester. For our first experiment, we tested the sapphire fiber optical and thermal properties to obtain a baseline data of the bare fiber before cladding. We started by using a lamp as the heat source, and then we used a torch for the next test. We recorded the spectrums every minute and used the peak wavelength created to calculate the temperature.
The goal for our second experiment was to create a uniform plan that is free from any defects. To do this, we perform a deep processing aluminum oxide nanopart solution. We heat treat the fiber and analyze the result using a scan electron microscope, the SEM. As can be seen in the figures, the results will demand a failure due to cracking.
For the third experiment, we heat treated the same fiber from the previous experiment, but with a protective jacket that we assembled. As you can see in this picture, the jacket performed excellent with no signs of damage.
The fourth experiment was identical to the third. The only difference is that we filled a gap between the innermost jacket wall and the sapphire fiber with a nanoparticle solution. We wanted to ensure that this filling would not alter the performance of the fiber and keep it stable. We found that this was the case. The fifth phase was our first industrial experiment. During this experiment, we tested the jacket assembly in a small crucible with molten steel, similar to that of our company's environment. This test gave us mixed results. We saw that the sapphire fiber performed as expected, but the jacket assembly experienced thermal shock and cracked as a result.
With this new technology, our company could realize $6.6 million annually in savings from procedure change. Along with this, they will save $165,000 a year with removal of one-time use sleeve.